Yeah, my name's Ben Weinberg. I'm in from Toronto, Canada. Are there any Canadians here? Lovely. Yeah, it's my first time in Seoul, so thanks everyone for having me. First time in East Asia, actually, so it's really, really cool to be here. But lots to get through, so let's get right to it. So first, we're going to start off with the need for Interchain, how we got here, why this all matters. We're then going to go into the problem with pairwise bridges as they've existed over the past few years. We're then going to get into Axelar, an overview of the Axelar platform and the advantages which it brings. We're then going to get into general message passing, or GMP, which is a really cool feature that I can't wait to show you guys. And we're going to go through a quick coding example of GMP as well. And then we're going to end off with the fun stuff, Axelar in the wild, see who's using it, what people are doing. So, get to this video in a second, but a bit about myself. I got into the space back in 2017, or end of 2017, during the ICO bull run. And at the time, the mentality that people had towards the blockchain space was that of chain maximalism. And that was the idea of one chain to rule them all. But one thing I've noticed is that chain maximalism is wrong. This never really happened. And if you can see here behind me, this video that I'm showing is from a website called chainless.org. And this shows many of the blockchains that exist today. I say many, not all, because it's impossible to actually say how many blockchains are really in existence. But you can see here, just going through chainless.org, there's hundreds, if not thousands, of blockchains that exist today. And these are many blockchains that are designed for different purposes, some for privacy, some for scalability, some for speed. We've even seen the rise of app chains, which are blockchains that are designed for one specific app use case or a few specific app use cases. And with these many blockchains in existence, I think you guys get the point. It's a little busy to look at. With these many blockchains in existence, liquidity is spread between different blockchains and communities are spread. So for us to be successful as a space, we need to solve the interoperability problem. And this is not a new thing that people have noticed. Pairwise bridges have been around for a while already. People have been trying to tackle this problem for years. And what we saw with pairwise bridges is the use of wrapped assets like WETH, sorry, you guys can't see, WETH or WBTC. And these are wrapped versions of assets which basically hold the same value of the token that they're wrapping. So one WETH is equal to one Ethereum in dollar value, one WBTC is equal to one Bitcoin in dollar value. And many of these bridges were using something called multi-sig contracts. So very briefly, for those who haven't heard of multi-sig contracts, a multi-sig contract is a design pattern which basically restricts a transaction being sent from one account to several accounts. So I can't just go and click my MetaMask sign and trigger a transaction. Rather, you need, in this case, three signers out of 4 eligible signers signing off on a transaction. So in this example, you can see myself, my younger brother, my parents, who did not let me use their picture for this. And you can see here that I don't want to sign, but 3 of them do want to sign, so the transaction goes through, which is normally how my family goes. The issue with multi-sig contracts is that they're great for some security if you want to just limit one person from holding all the power. But for bridges, which are sometimes holding hundreds of millions of dollars, having just a multi-sig, a 3 of 4, even a 5 of 8 multi-sig is just not good enough from a security perspective. And this is very clear. We've seen some of the biggest hacks in the blockchain space to date. You can see behind me have been attacks on bridges. So top left is probably the most famous one. The Ronin network bridge was hacked for $625 million. The Poly network bridge was hacked earlier this summer. Ironically enough, it was a 3 of 4 multi-sig contract whose keys were compromised. And there's many more than just these 4 that I have on stage here. And you can see Chain Analysis actually has an interesting article. They claim that 69% of total funds stolen in 2022 in the entire crypto space, it's about $2 billion worth, was stolen from attacks on bridges. So what do we know? Where are we? We know that we need interoperability. This idea of chain maximalism is wrong. It never happened. But we know that there's room for us to improve as a space for how we tackle interoperability from just having multi-sig contract bridges. And that is where we get to Axelar. So what is Axelar? Axelar is a blockchain that connects blockchains, enabling universal Web3 interoperability. And that is a bit of a loaded sentence there, so I want to break that down a bit for you guys. And I want to focus on universal Web3 interoperability, these last 3 words. So the easiest way to visualize Axelar is this diagram right here. It's a hub and spoke model connecting many different blockchains to each other through the Axelar blockchain. And remember those 3 words, universal Web3 interoperability. What do I mean by that, and why am I calling this out so specifically? Well, if you look at some of the blockchains right here that are connecting to Axelar, you can see what I mean. We have projects like Ethereum, Polygon, Avalanche. These are examples of EVM or blockchains, projects that are running the Ethereum virtual machine. We have projects like Osmosis, Juno, the Cosmos Hub, projects from the Cosmos ecosystem that are built with the Cosmos SDK. We even have at the bottom right there Arbitrum, we have Linea, we have Base. These are layer 2 protocols that are built on top of Ethereum. And you can see we have many different blockchains that are now able to connect to each other. It doesn't matter which virtual machine they're running, which consensus mechanism they're running. Axelar enables universal Web3 interoperability. And out of the box, there are 2 major improvements which Axelar brings. Those are scalability improvements and security improvements. And I'm going to go to scalability first. If you picture pairwise bridges, and we have an example here with 3 blockchains. We have Ethereum, BNB, and Polygon, 3 blockchains. For these 3 blockchains to each talk to each other, we need 6 bridges. You can just count them right here. If we want to throw in one more blockchain, let's say Avalanche, just for one more blockchain, we now have 9 bridges. And you can imagine, like with what I was showing you guys earlier with Chainless, with the thousands of blockchains that exist there, how many bridges we'll need to connect each blockchain to each blockchain. Rather, with Axelar's hub and spoke model, all you need to do is plug into Axelar, and immediately you can connect to any other blockchain that's also plugged into Axelar. And the way I like to kind of think of this in my head, as with these pairwise bridges are kind of like train tracks. You can go from point A to point B, and that's it. Whereas Axelar is more like an airport. Once you have an airport in your city, you in theory can get to any other city in the world that also has an airport. So it scales way, way better. The other major improvement, if you look at the second point here, is security improvements. So I touched on this a bit earlier, but Axelar is a blockchain for blockchains. So what does that mean? Axelar is built on the Cosmos SDK. It's currently running proof of stake, run with 75 live validators. Any of you in the Cosmos ecosystem might be familiar with some of these validators, like Figment, Informal Systems, Pokachu. These are well-known validators within the Cosmos ecosystem who are validating many other blockchains in addition to just Axelar. And you can imagine that having an actual proof-of-stake consensus mechanism, maintaining interoperability within layer 3s within the blockchain space, is a huge step up from just having like a 3 of 4 multi-sig contract maintaining interoperability. It's actually really exciting to think that what's maintaining interoperability is a blockchain, just like how the blockchains that they're connecting between, we're just having a blockchain connect them. So it's a tremendous step up from just a multi-sig contract. But what I really am excited to show you all is general message passing, or GMP. So if you recall what I was saying earlier, much of interoperability in the early days has been just using like wrapped assets like WETH or WBTC on different blockchains. What general message passing allows us to do is true interoperability, in my opinion. So you can see here on the left, we have myself on Ethereum, which is a picture I found of me in my first ever blockchain event. Spent way too long looking for this. And myself on Avalanche. And I'm basically having a conversation between myself on the 2 blockchains. So you can see the first message here is like, WAGMI, are we going to make it in this crazy lovable space of ours? And then I'm responding here with safe mint 5 Bored Apes. So what am I trying to show here is that in addition to just sending like hello world messages, general message passing goes a lot further than just saying like, hey, WAGMI. What we can also do is actually call functions on different blockchains. And that to me is true interoperability, because we can actually interact with contracts and applications on different blockchains as easily as if we were interacting with these contracts on our own blockchain. So very quickly how this works, and this is granted a simplified diagram, but I think it illustrates the point pretty well. Let's say we have an application that is trying to send an ERC20 token from the Ethereum blockchain to the Polygon blockchain. Now, the way Axelar works, any blockchain that is connected to it has something called a gateway contract. The gateway contract exposes several functions which we'll need to use to trigger and receive an interchain transaction. One of those functions is call contract with token. This is a function which we need to use to initiate the interchain transaction. When we call contract with token from our dApp, the gateway contract will emit an event. That event will be picked up by the Axelar network, which, remember, Axelar network is a blockchain. So the validators on the Axelar network will be coming to consensus. They'll be saying like, hey, did Ben really send this ERC20 token? Once they come to a consensus, they basically mark the message as approved. And then the gateway contract on the destination chain on Polygon, remember each blockchain has a gateway contract, will via something called a relayer trigger the execute with token function. And with the execute with token function, we'll be able to receive the message and the token that was passed onto the dApp. Now, I know that was a mouthful, and I will show you all in the code how this works, but one more time at a very high level. Our dApp uses the gateway contract. In this case, we're using the function called contract with token. Gateway emits an event, gets picked up by the Axelar network, which comes to consensus about the event that was sent. That notifies the gateway contract on the destination chain, which then via the execute function triggers our dApp on our destination chain. So let's see this in action. Let's make this bigger here. I'll sit down so you guys can see. So here we're going to write out the contract very quickly that basically will describe sending an ERC20 token from one contract to another. So at the very beginning, standard stuff, we're importing our ERC20 interface from OpenZeppelin. We then import our Axelar executable, which I will come back to that later. We then import our gateway contract. Does anyone remember what that is? That is this guy here that we were just talking about. It's what exposes the functions that we need to trigger an interchain transaction. So we import the interface for that. And then we import the interface for the gas service. Now, a brief tangent here. What is the gas service? The gas service is a really handy feature from the Axelar team, which assists with paying gas in an interchain transaction. Now, what does that mean? If you think about it, here we're trying to send a token from Avalanche to Polygon. And remember, Axelar is a blockchain of blockchains. I know I'm saying that a lot. But given that, we need 3 different tokens. We need AVAX to pay the gas on the source chain. We need AXL to pay the gas on the Axelar blockchain, which is kind of sending this message. And then we need Matic, which is the gas of the destination chain. And I don't know about you guys, but it's a pain to have 3 tokens every single time you want to send an interchain transaction. And that's where the gas service comes in. It basically allows us, it handles the gas payment for us so that all we need is the gas from the source chain, and it pays the gas for the Axelar blockchain and for the destination chain. So if I'm sending from Avalanche to Polygon, all I need is AVAX, and I'm good to go. Just to be clear, that doesn't mean that they actually pay the gas for us. The money still comes out of our pocket in the end of the day, but it comes out in the form of AVAX. We don't actually need the Matic and the AXL. So I'm not going to write out the code. I'm going to switch between branches to speed things up here. But the first thing we do here is just pass in the address of our gateway contract and our gas service contract. Remember what I said, these contracts exist on every single blockchain which is connected in to the Axelar ecosystem. So we set those addresses here. Next, we have the send to many function. This is the function which we're actually going to be using to trigger our interchain transaction. It takes 5 parameters. So the first one is the destination chain. This is going to be Polygon. That's where we're going towards. The destination contract address. This is going to be this whole contract, which will be deployed both on Avalanche and on Polygon, because we're going to need to receive and handle some functionality on our destination chain. Third parameter is destination addresses, which I also will return to in the future. Then we have symbol and amount. This is our ERC20 token, like which token are we sending and how much of this token do we want to send. If we go to step 4, we start writing out this function. At the very beginning, we want to make sure that some gas is sent. If not, throw a revert the transaction and say like, hey, gas payment is required. We then, via the gateway contract, pass in the symbol of the token that we want to send. We're going to send a wrapped version of USDC. And the gateway will return the address of this token. All we need to provide is the symbol, and it gives us the address. Then, these next 2 lines are some standard ERC20 functionality. We transfer the funds from myself to this contract. We then approve the gateway contract to handle this token on behalf of us. Then we encode this third parameter, destination addresses, which I promised I would return to. So what are we doing here? We are sending an ERC20 token from one blockchain to the other. But remember, what I really wanted to show you guys was general message passing, which is more than just sending a token. It's actually sending a message along with the token. So in this case, the message we're going to be sending is a list of several addresses with the token. And to send that message, we have to encode it. That's what we're doing here. But why are we sending a list of addresses? Well, you're going to see later on in the contract what we're going to do with those list of addresses is actually send tokens to those addresses. And we're going to try actually send an equal amount of that token to each address. So we're doing a lot more than just sending tokens. We're sending tokens and a message to compute some logic along with the token that's being sent. And you'll see what I mean very shortly. First thing we have to do is finish up writing this send to many function. Our last thing we have to do is with our gas service and with our gateway contract actually trigger the interchain transaction. So for gas service, we call this very long named function, pay native gas for contract call with token. All what this is saying here is saying, hey, which destination chain do we want to pay gas on? So in this case, we're sending to Polygon, so we're telling like, hey, we're going to need some Matic for this transaction and pay it on behalf of this contract. Then we call contract with token. If we recall this slide here, that is this function here, which is being presented to us by the gateway contract. So we call this function and we pass in the 5 parameters that we defined up top here. So those are the destination chain, Polygon, the destination contract address, this whole contract, which will be deployed on Polygon, our encoded GMP message, which is our list of addresses, our token symbol, and our token amount. So at this point, once this function gets called, we will have successfully sent a token from Avalanche to Polygon with this message and this token. But now we're not done yet. We have to do something else. What is that? Once we're on our destination chain, once the transaction has been sent out of Avalanche to the Axelar network and is received on Polygon on this right side of the table, we want to do something, right? And for that, we have to use this internally defined function here, which is being presented to us by the Axelar executable contract. And that, if you recall this diagram, is this function right here, number 4. So at this point, when this function gets called, we're on the other side of our transaction, and we're going to have received an ERC20 token and a message. The only really important parameter for you guys that you need to know is the payload. If anyone can guess what it is, that is going to be our message, our list of addresses that we passed in. And then our final step here is we decode the message, so now we have our list of recipients. We grab our token address again. We then run some very simple logic, which is take the amount of tokens that we sent. Let's say we sent 6 tokens with 3 addresses. We divide the 6 by 3, which is how many tokens we're going to send to each address, which is 2. So we send to each of those addresses 2 tokens, and that's what we do here at the very end in our for loop. Next, I called this before just for time's sake, but I'm using the hard hat CLI. So what we did was deploy this contract on Polygon, which gives us our address here, on Avalanche, which gives us our address here, and then we trigger the send to many function, this guy, right here. We pass in the name of the destination, Polygon, we pass in the address here, which is this address, which was deployed on Polygon right here. See, that matches here. We then pass in our array of 3 addresses. This is our GMP message that we're sending with the ERC20. And then our token symbol, AUSDC, our token amount, and some gas. This then spits out a hash. With this hash, we can now go to a really cool feature that I'm very excited to show you called the Axelar Block Explorer. This really shows us the guts of the interchain transaction. So all what I have to do is paste the transaction hash in here. And hopefully, we should be seeing this transaction come up. So here you can see the let me make this bigger for you guys. You can see the step-by-step of an interchain transaction. You see it was sent here on Avalanche. You can even click on these symbols, on these logos right here. So if I click on this, for example, it'll take me to the transaction on the Avalanche Block Explorer. I apologize for the light theme. You can see it gets sent from Avalanche. The gas gets paid. It gets confirmed on the Axelar blockchain. Then on our destination chain, we actually send this function. So I apologize again for, let me go to dark mode here. But you can see now our final step of our interchain transaction, our 6 tokens gets divided into 2 tokens, which is sent to each of those 3 addresses that we passed in. So it worked. The next thing I want to show you, I'm going to wrap up quickly. I know I'm low on time here. There's some applications which are actually using Axelar today. I'm going to stand up for this one. Squid. Squid is an example of an application which is using Axelar GMP for several things, but one of the use cases which they have is like a little token swapper here. So you can see for anyone who's used Uniswap, this UI probably looks very, very familiar. But unlike Uniswap, where you can only select the 2 tokens which you want to swap between, you can also select the blockchains which you want to swap between. So here we have like the Ethereum blockchain with the Graph token, GRT, and I'm swapping this with USDC on the Optimism blockchain. So I can actually go between 2 blockchains in one click, one transaction with the Squid router, which is powered by Axelar. This is another, I think for time's sake, I'm going to have to skip this, unfortunately, guys, unless I have time. But skip it? Oh, I can go. OK, this is a really high-level overview of a new feature which Axelar has coming out called the Interchain Token Service. It's a really, really exciting feature which is coming out hopefully in just a few weeks. It's already live on testnet. And what the Interchain Token Service allows us to do is to actually deploy tokens on many different blockchains all at once. And then those tokens are interoperable with one another on different blockchains. We can also do the other way around. If we have a token which is already deployed on one blockchain and we wanted to make it cross-chain, then we can wrap it here with the Interchain Token Service and actually allow it to be sent between chains. It's a very easy way to go interchain. So I have a brief screen recording, it's only 30 seconds, of me deploying an Interchain token. So you can see how easy it is. I name my token, decimal points, I'm deploying it on Avalanche. Let me pause it here. So you see it's being deployed on Avalanche right now, but I can also select, oh, it didn't pause. Try that again. I can also select the other blockchains that I want to deploy on. So you see here I'm deploying with Avalanche, but I'm also going to select, hey, deploy on Polygon. I can deploy on all these chains if I want to, but I'm just doing Polygon for now. And then you'll see once it gets deployed on Polygon, and let's say 2 weeks later I want to deploy on other blockchains, I'm also going to deploy here on BNB and on Arbitrum. Really just a few clicks and I'm good to go on all these different blockchains. So really, really powerful stuff, and I hope you all get a chance to use it. It's really, really cool. And I think that is it for me. Just some numbers I wanted to show you guys, if that is not exciting enough. This is from Axelar Scan, the website we just saw, and this is some of the transaction volume that's been going through Axelar. You can see here on the top left, 103,000 GMP transactions have been sent. $4 billion of liquidity has been sent over the Axelar network. We're at 49 connected blockchains right now. I can't wait to say 50. It sounds a lot better than 49, but we're at 49 right now. And the really exciting part, this $4 billion and 100,000 transactions, that's just the last month. So this is a really, really exciting time to be learning about this stuff. I hope as many of you can look at this as you can. But yeah, the space is growing very fast right now. It's really, really exciting. And here are some resources if anyone wants to go a little further. On the left is a series of dev tutorials. It's basically YouTube videos explaining the code example I just showed you guys and much more. On the right are the actual code examples. It takes you right to GitHub, and you can see completed end-to-end code examples with the front end being wired up to all the examples, which is like the ERC20 example and many more exciting examples. We good? We got? Yep. Good? And that is all for me. Thank you very much, everyone. My name is Ben Weinber. If you have any feedback on something you liked, something you didn't like, let me know. Any questions, I'll be around probably for the next few hours. So come talk to me, email me if you want. Thank you very much for listening.